So here we have Dr. Rupam Srivastava, who's an assistant professor at Madhav Institute of Technology and Science and located in Madhya Pradesh. She has completed her PhD at Motherton Nehru National Institute of Technology, Allahabad, Prayagraj. Her main research interests include optical sensors with a particular focuses on emerging technologies related to surface plasmon resonance and photonic crystal fiber. She has many academic and research contributions, mainly supporting the advancement of smart sensing technologies and their practical applications across various sectors. We are very honored to have her today. So I'll honor the stage to her to present her presentation. Yes.
Thank you so much, ma'am. So I am Dr. Rupam Srivastava. I am here to present about fiber optics and their applications in sensing, that is the role of machine learning, especially here. So I would start with the contents from motivation, introduction, SPR means surface plasmon resonance, conventional fiber optic based sensors, then photonic crystal fiber, then reported works in the literature, then recent developments, and then what are the challenges in this field and how the machine learning can overcome these challenges, and what are the future trends and research directions, and finally conclusion. So first of all, I would like to discuss about the motivation behind using the surface plasmon resonance based sensors. Conventionally, there are many methods, many conventional methods like ELISA, PCR, flow cytometry, chromatography. These methods are used to detect various analytes or various bioanalytes, but there are some limitations, or we can say, in the conventional methods. Like these methods require very large sample volumes, high cost, longer turnaround time, extensive sample pre-treatment, and skilled staff. So in order to overcome these mitigations, the surface plasmon resonance technique has emerged as a very effective technique, which has several advantages like non-destructive, label-free detection, high sensitivity, versatility, lower cost, and fast response. So this is all about the motivation. Then surface plasmon resonance-based sensors can be applied in various fields like medical diagnostics, agricultural field, environmental monitoring, chemical sensing, glucose monitoring, etc. So the basic building block of the optical biosensors are, first of all, sample, which is to be detected. Then BRE means biorecognition element, optical transducer, which will convert the truthful information which can be detected, and the signal processing unit. These are the basic components. Then what is the what is the fundamental of the surface plasmon resonance? Surface plasmon resonance occurs at the metal dielectric interface when the electrons of the metal collectively oscillates at the surface of the metal and dielectric, and at a particular condition that is called as resonant condition, this happens. So this can be happen through two ways. One is angle integration method and other is wavelength integration method. In angle integration method, at a particular angle of the incident light it happens, and in wavelength integration method, at a particular wavelength of the resonant or at a particular resonant wavelength of the light it happens. So we can say that at the resonant condition, the propagation constant of the surface plasmon waves and the propagation constant of the light, that is basically evanescent field of the light, both becomes equal, then this satisfies the criteria for surface plasmon resonance to happen. So these are the traditional methods, which is based on the prism. So the prism is very bulky and uh, it requires a heavy setup. So in order to overcome, we use the optical fiber based SPR sensors. Optical fiber based SPR sensors can potentially overcome these limitations. These are compact, cost effective. These are miniaturized and suitable for remote sensing also. So we know that the structure of the fiber consists of mainly two things: core and cladding. And what happens in this? This uses basically wavelength integration method. At a particular wavelength, there is a certain dip in the transmission characteristics of the light, and if the surrounding medium of the fiber, that is called as sensing medium of the fiber, changes, then this wavelength resonance condition also changes. So with this, we can detect different analytes. Uh, this is called as PCF or photonic crystal fiber Photonic crystal fiber is also fiber, but it is an improved version of the conventional fiber. It has several advantages, like it offers design flexibility and possibility to control the light propagation. It has single mode pore operation or confinement loss, and it has very high strength evanescent field. We can control the several characteristics of the fiber, with the help of which we can improve our sensing performance. So it consists of basically core and cladding, but the core and cladding are in the form of air holes. Here we can see the relation between the, in figure 1.5 we can see the relation between the simple or traditional fiber and photonic crystal fiber based sensor. So these are basically of two types. The first one follows the index guiding mechanism, which has solid core, and second one follows the photonic band gap mechanism, which has hollow core. The first one is having a positive effect index profile, and second one is having the negative effect index profile. First one follows the principle of total interval reflection, and the second one, that is the photonic band gap PCF, follows the principle in which the light is guided through the photonic band gap property. And these are the performance parameters which are to be detected while the analysis. So first one is confinement loss. Second is the wavelength sensitivity. We can also obtain the sensitivity with the help of amplitude sensitivity method, and another parameter is resolution. Some other parameters are also there, like FWHM, full width at half maxima, figure of merit, etc. These are the different reported works in the literature by different researchers. These works contributes like different PCF structures, how to optimize the structures, and how to use different materials so that the performance can be improved. So these are some recent PCF based SPR sensors using finite element method. In this structure, a D-shaped optical fiber or a D-shaped PCF photonic crystal fiber sensor has been taken, in which the gold is utilized as a plasmonic material here, and different white color indicates different types of air holes, and there are three types of air holes: white, red, and green color. These air holes have different diameters. These air holes are optimized in order to achieve the optimum sensing parameters. So the values are also given in the table. So these are figure 1.9 indicates various modes, that is core mode. First one indicates the core mode. Core mode in which the light is confined in the core of the photonic crystal fiber. Second one is that is figure B. It is the coupling mode in which the light is coupled from core to the surface at which the light is placed. And third one is the SPP mode, surface plasma polarization mode, in which this indicates the resonance condition in which the energy, in which the maximum of the energy is transferred at the surface, or we can say at the metal dielectric interface where the analyte is placed. And figure 4.3 indicates the confinement loss. In this figure, we can see that there is maximum loss occurs at wavelength approximately equal to 1.36 or 1.37 micrometer. This wavelength is called as resonant wavelength, this at which the surface plasma phenomena takes place. So these are the different results of the same proposed work for the different analytes. That is, analytes ranging from the refractive index 1.30 to 1.40. And first figure 1.10 indicates the wavelength sensitivity, and figure 1.11 indicates the amplitude sensitivity. Similarly, these are also this work was basically proposed by our group, in which the detection has been performed for different stages of the tuberculosis, that is ring stage, Schizonen stage, and trophozoite stage. And these graphs are all about these three stages, in which we can see that when the stages, these stages are obtained from the blood plasma. If the blood plasma will change, then there will also change in the refractive index of the blood plasma. Then the resonant condition will also change, from which we can detect detect the different types of sensing medium. These are the reported works, and similarly, this work is for this work tells about the D-shaped photonic crystal fiber with high sensitivity for detection of tuberculosis, and in this the sensitivity is improved by implementation of 2D material or different types of materials like magazine and MS2, and here gold is acting as a uh, plasmonic material, and here the sensitivity has been improved by depositing the gold material at the uh, this circular area, semicircular area. So the distance between the core and the analyte has been reduced, so the sensitivity has been increased because the coupling has been strengthened. Uh, Similarly, these are figure 1.16 A, B, and C represents the core mode, coupling mode, and SPP mode. And these figures, these results indicate about the uh, confinement loss for different analytes. This table is all about the previous results. This has been tabulated. Here we can see that our proposed work has obtained the maximum sensitivity of 45,000 nanometer per RIU, where in comparison with the reported literature works. Now, what are the challenges in traditional optical fiber sensing? So the challenges in traditional optical fiber sensing that involves that the since we have already seen that photonic crystal fiber. So photonic crystal fiber has in order to improve the performance, there are several geometrical parameters like air hole diameter, the thickness of the metal, or the shape of the PCF photonic crystal fiber. So there is lot of structural complexity. So we have to optimize the geometrical parameters sometimes in hit and method, and also there is the requirement of large data generation, and sometimes the issues of sensor calibration also happens, and there is also high installation cost and environmental sensitivity. If there is change in any environmental parameter, then these sensors are also sensitive to the environment. So these are the challenges. In order to overcome these challenges, we can go towards the ML solution, that is machine learning based solutions. So machine learning based solutions offer what these solutions offer. These solutions offer to predict the failures. We can optimize, we can relate, we can establish a relation between the different types of geometrical parameters, different types of output parameters like sensitivity, confinement loss. So we can predict failures. The measurement accuracy can be improved, and the false alarms can be reduced. So these are the ML solutions which are offered by different types of ML models. And this can also be applied in diverse domains such as healthcare, transportation, agriculture, plasmonics, and biosciences, etc. So there are what is machine learning? Machine learning is a branch of artificial intelligence that enables systems to learn patterns from data and improve automatically. There are various types of machine learning techniques like supervised learning, unsupervised learning, and reinforced learning. And ML machine learning workflow basically consists of, first of all, in the first stage, data collection is very important because the machine learning requires a huge amount of data. And then after data pre-processing comes, then feature extraction. Feature extraction is all about the extraction of the important features which are very important in the process of detection or prediction. Then the model is trained, and after that prediction is performed. So this is basically about the machine learning workflow. So there are various nowadays PCF-based SPR sensors also comes with the solution of machine learning approach. So these are some reported work in the literature. So first one is about the performance optimization of PCF sensor using machine learning. Here we can see that photonic crystal. This is not about the photonic crystal fiber. This is a simple traditional optical fiber which has been used as a sensor, and the machine learning models like here we can see that CatBoost, XGBoost, ANN, and random forest models are implemented in order to train the model and predict the model. And And these results are compared here in the figure. So in these figures, we can see that this figure is all about the figure of merit and resonant wavelength. The graph between the figure of merit and resonant wavelength, we can see that there is the similarity between the actual and predicted models in all these models like QuackBoost and random forest models and XGBoost. There will be some difference in the prediction error, obviously, but these are all very near to the actual model actually. And similarly, the second work, this work is about the photonic crystal fiber based sensor, which utilizes gold as a plasmonic material. And this figure indicates about core mode and SPP mode. And this setup is the workflow of the research procedure in which the first of all model is simulated, then meshing the model, then computing the result, then data sets are generated, and with the help of these data sets, the data set is pre-processed, then data is split in trained data and testing data, and after that, the ML model are trained and prediction is performed, and then we can validate the performance. So here we can see that the comparison between the this is for the RFR model, and for the graph between N effective and wavelength. N effective is a very crucial parameter that is called as the effective refractive index in the PCF-based SPR sensors, which is responsible for the confinement loss detection. So these are the different machine learning models, which has been compared, and their corresponding MSE values and R squared values are given in this table. So what are the future trends and research directions in the machine learning based PCF SPR sensors? In future, sensors can also will make the use of intelligent decisions independently, and that will be known as smart sensors. Edge computing, these sensors can also be utilized in the real-time processing near the sensor location, that is known as edge computing. And nowadays, there is a trend of Internet of Things. So these sensors can also be integrated with the IoT or Internet of Things with the cloud, with the help of cloud platforms. And also these sensors can be utilized in the optical quantum sensing, that is an emerging field for ultra-sensitive measurements. Conclusion: fiber optic sensing is an advanced technology which is used for the accurate and reliable monitoring. It provides very high sensitivity, high precision. This can be used for long distance sensing, and these sensors are also immune to the electromagnetic interference, and these sensors can be used in the harsh environment also. But these sensors faces some challenges like the optimization of the structure or complex signal analysis or data processing. So in our as a solution, machine learning can improve signal analysis, fault detection, and real-time monitoring. The integration of fiber optics and machine learning enables smarter, automated, and more efficient sensing systems. My sincere acknowledgement to Professor Dr. Yugin Kumar Prajapati, professor at and my supervisor at the Department of Electronics and Communication Engineering, Motilal Nehru National Institute of Technology, Allahabad, Prayagraj, Uttar Pradesh, and also Lab for Photonic Devices and Communication, MNIT Allahabad, Prayagraj. Thank you. Thank you, everyone.
Thank you, Dr. Rupam, for the wonderful presentation. It was like I was wondering, like you said, there are many challenges like with the fiber optic sensing, and then you did give us like solutions, but like more like in the monitoring level. But being as a futuristic approach, like how do you assume like those challenges could be like permanently like not be minimized or like be permanently like not have any challenges? Because like most solutions were like really based on like monitoring or like giving some type of false alarm, but there was not like a permanent solution to it. Or are you like currently working on that?
Yes, actually, both has their own advantages. Like you have told that how can we the conventional methods in which we are not using the ML models. The PCF sensors are very sensitive, and these actually, what are the challenges in PCF sensors? These sensors require the optimization for the geometrical optimization or the laboratory setup or the experts. So in order to overcome these challenges, we can use the ML models. While ML models also have their own challenges, like we require large set of data. So uh, both have challenges, but if we can integrate, then we can utilize the advantages from both the techniques.
So it's like mostly gonna be like a combination of like the.
Yes.
And when you said like about MSc calculations, what does that really mean? Like the
Sorry.
for the MSc calculation, the output on the slide where you're talking about the outputs, like you
Yes,
said, like MSc calculations,
means
but I would just like to expand on what you mean by MSc calculation. Like, what does it mean?
means ma'am, actually there will be some certain error between actual and predicted value. So we can calculate the error, that which model is giving the least error, means mean square error. So that is the calculation of mean square error. That is different for the different models. That's good.
Okay. Thank you for clarifying my doubts. And to be saying like our company is also like related to like nano sensing technology and like magnetic plasma related sensors. Even today, like we have a presentation like for our like partnership with France regarding this, like where we're building like a sensor that is gonna like detect like the deportation thing. So I think like if you stay behind, it will be very appreciated. You could also like have our input on our presentation. And additional to my questions, there are some questions on the chat. If you can answer that, please. So there's one that says, how can digital twins be combined with fiber optic sensing data for predictive maintenance in industrial systems?
Digital, sorry ma'am, can you repeat the question?
It's saying, how can digital twins be combined with fiber optic sensing data for predictive maintenance in industrial systems?
In fiber optics,
Yes.
basically. Okay, so ma'am, basically with the help of machine learning, with the help of machine learning. So ma'am, with the help of machine learning, we can use the data which we have already obtained from the simulation or experimental. We can use both the data which we have obtained from the
Partly you
experimental work.
explained in my question as well how we are combining the old and the new advances together, like based on it.
Yes, ma'am. Yes.
Yeah. And another one is talking about like what future breakthroughs can you expect from fibers optic sensing, like by transforming into fiber optic sensing for like autonomous monitoring systems?
Yes, ma'am. We can use in different fields. There are different breakthrough can be used in different fields, like quantum computing, like edge computing and IoT based applications. So there are very emerging areas where it can be utilized.
Thank you for patiently answering our questions.